quartiles. Quartiles means quart means 4, tiles means parts, means 4 parts. So to divide the data into 4 parts, you need 3 cuts, right? So the middle cut is very clear, is the median, right? It's a cut at half of the data. So half, like the median, is half of n plus 1, right? It's because if the 3 data, 3 observation, and the middle one, the second one, right? So this is n plus 1 over 2. And the first one will be 1/4 of n plus 1, right? And then the third quarter will be 3 over 4 of n plus 1. Okay, so this means quartiles. So as we mentioned before, range is the maximum minus the minimum, and this subject to the changes the maximum minimum. If you maximum minimum changes a lot, then the dispersion measured by range will change a lot, right? Because when you do sampling, you collect data, then the maximum minimum can easily change. But if you replace the maximum by the third quartile, the minimum by the first quartile, then if you change the maximum minimum, doesn't really affect the difference between the third quartile and the first quartile. So that's why we define this interquartile range as a way to measure the interquartile range, measure dispersion. And we mentioned in principle what is first quartile, second quartile, third quartile. The second quartile is easy, is a median, right? But how to find this? The first quartile and the third quartile is a little bit not easy, right? Because remember, even in the median, the second quartile, look at the median. When the number of the data, number observation is odd number, then we exactly the middle one, we can find the median. But if an even number, then the median will be the middle two, the average of middle two, right? So then to consider a quarter of the data, then it will be a little bit tricky, right? Because if exactly we have a multiple of the data that is n plus 1 over 4 is a integer, then we can exactly pinpoint where is the first quartile. But if not, if n plus 1 over 4 is not a whole number, if it's a decimal number, right, it can be 0.5, right? Maybe 0.25, maybe 0.75, then we have to do some average, right? Basically 0.5 with average of the two neighborhood number, right? But if it is a 0.25, then it's a weighted average, right, of this neighborhood two number. If a 0.75 will be neighborhood of the two number. So then the calculation can be a little bit more tricky, right? Can be a little bit more complicated. So that's why when you calculate this IQR, there's some shortcut. So we talk about 2 shortcuts, and then at the end we talk about the real way, the more official way to do it. But bear in mind, there's no official way, so-called official way to calculate. There's many ways. If you look at the software package, there are many ways. But this here we just tell you 3 common ways to do it. So the first 2 is a simplification. That means that we use the way how to do median to find interquartile range. So first we have said the median is uncontroversial. It will give you the second quartile, right? And then we will use this median to divide the data in 2 parts and find the median again, okay, in these 2 halves to calculate the first quartile and the third quartile, and then we have IQR, okay? And with the median to be included into the 2 halves will be the main difference or the only difference between the method 1 and method 2. So median, so first we do is use the median to cut the data into 2 halves, okay? If n is odd, then the median will be in the data. If n is not odd, then it's not in the data, right? And then you have 2 half data, okay? And then use these 2 halves to find the median. And then we have Q1 and Q3, okay? And the difference will be the IQR. Method 2 is the same, but this part median is no longer included, okay? So this is the different part is whether it's included or not, it's not included, okay, in this case. So when the observation number of observation is even, then the method 1 and method 2 are exactly the same. So that is the way to simplify IQR, just find the median. Okay, and whether you want to use method 2 doesn't really it maybe matter if the number of data is small, but you have to make a decision which one is the better use. And method 3, as we said, we will use exactly the definition of 1/4 over n plus 1 data, and Q3 will be third quarter of the n plus 1 rank data. So how do we define? It's very similar. So we define this floor function, which with just the integer. Okay, we forget about the decimum, just integer part. Okay, so we have a small q function, a quantile function. Okay, quantile function. This small quantile function, okay, is take the argument p, which from 0 to 1. Okay, this q0 gives you the minimum number. Q1 is the maximum. So q of 0.5 will be the median. Q of 0.25 will be first quartile. Q of 0.75 will be the third quartile. Okay, so how do we calculate? So as we see, that will be, by definition, that will be p times n plus 1. Okay, and if this is exactly the whole number, right, then k whole number, then this floor function will mean nothing, right, because floor function of integer is the same itself. And this alpha will be the decimum plot, right, because this is, we take the smallest integer, right, and the difference will be decimum plot. So when this is a whole number, this alpha will be 0. So the small q will just give you exactly the location of this number, right? So basically, if you p times n plus 1 is an integer, right? So if you p is half, n is an odd, right, then k is a whole number. Then q of half will be exactly will be n plus 1 over 2, right? Exactly what we want. But when this is not, then we need to add a little bit more, right? Because we took the average of the two, right? So suppose we have half, right? It's median, usually it's half or whole integer, right? Half will be half of difference between these two. So basically it's the average of these two numbers, right? Because half of this, right, and minus half of that. So you clear up this half of xk and half of xk plus 1, okay? So if it's 0.25, then you will be, alpha can either be half, right? Can be 0.25 and 0.75 because this is a fraction of a denominator of 4, right? Because p is either 1 over 4, right, and 3 over 4, right, or half. So it's either 0.25, 0.75, and 0.5. Okay. Okay. So this looks a little bit tricky, but let's say example. Then you see how we operationalize this procedure. Okay, it's not difficult. So let's look at the first example. So we have a data of 5 data point, which is 1, 2, 3, 4, 5. So we're clearly the median will be 3 because we have a odd number of data, right? And then you count the middle one, right? If 5 plus 1 is 6, 6 divided by 2 is 3. So it's the third data. So 1, 2, 3. Okay, the third one, median 3. So the method 1 is said use the median to cut the data in half, and median is included in the first half. So this 1, 2, 3 is the first half, right? Same as 3, 4, 5 will be the second half. Okay, 3 is included here. Okay, and look at 1, 2, 3. Okay, the median is 2, right? And look at 3, 4, 5. The median, the middle one, is 4. So the IQR is the difference between Q3 and Q2, which is 4 minus 2 is 2. Okay. The second method, again, we found the median, 3. But now the median should not be included into the halves, right? So that's why the first half is 1 and 2. Second half is 4 and 5. And 1 and 2, the median, okay, will be the average between these two numbers, which is 1.5. 4 and 5, the median will be, because two numbers, the median will be in the middle, right? So there will be an average of these two numbers will be 4.5. So the difference, the IQR is Q3 minus Q1, which is 4.5 minus 1.5, that is 3. Okay, so you can see when I have number of the data, number of observation is odd, right? So you can see the method 1, method 2 will give you a different answer. And the next example, you will see when they're even, they will give you the exactly same answer as we have said. So now we look at the most elaborated one. Okay, look at the most complicated one. Okay, we exactly look at the definition of Q1 and Q3. Okay, so for Q1, okay, will be 0.25 times n plus 1, right? This is P, right? Which is because Q is Q1 correspond P is 1/4, right? And then this is n, right? N plus 1. So it's 6 plus 0.25, which is 1.5. And 1.5, take the integer, which is 1, so k is 1. And you take the decimum part, which is 0.5, okay? So that's why you take the first observation, which is 1, plus, because alpha is 0.5, which is alpha, right? Alpha. And then you take the difference between 1 and the next observation, so which is 1. So that's why it's 1 plus 0.5, which is 0.5. And Q3 the same. So Q3, the P will be third quarter, and N will be 5. So that's why we have 4.5. Okay, 4.5, you take integer with 4, and the decimum part will be 0.5. So we have the fourth data because k is 4, right? This is 4 here. This give you 4 here. And we have alpha is 0.5, okay? Alpha is 0.5, this gives you by that one. And you have 4 and the 5 difference, which is 1, so it's 4.5. So the IQR of the difference will be 3. So in this case, 3 is same as 2. Okay, method 2, 3 is method 2, but it's different method 1. Okay, so let us see the example 2. Okay, we have 6 data points. So we odd number of data. So you expect method 1 and method 2 the same. So let's see whether the same. So we have 6 data points. So the median will be n plus 1 over 2. So 6 plus 1 is 7. 7 over 2 is 3.5. So it's average of the third and the fourth one, right? Average of 3 and 4 will be 3.5. And the first half will be 3.5, so it's here. So you just get the first 3, 1, 2, 3. Second half will be 4, 5, 6. Then 1, 2, 3, the median will be 2. 4, 5, 6, the median will be 5. The difference will be 5 minus 2, which is 3. And second method the same, because the median is not data, so all the procedure in method 1 remain the same. So last, the method 3. So a little bit elaborated, but you know how to do it. Q1, okay, correspond to P equal to 0.25, 1/4. And with 6 number of data, so it's n plus 1 is 7. 7 times 0.25 is 1.75. So the integer part is 1, and the decimum part is 0.75. So that's why we have x1, because k is 1, and 0.75 is alpha, and plus the difference between x1 and x2. So it's 1 plus 0.75, so it's 1.75. And in this case, Q3 will be almost the same, but now the P is 0.75, right? Because it's third quartile, is 3/4. 3/4 plus n plus 1, so it's 7 times 0.75, which is 5.25. So the k, the integer part is 5, and the decimum part is 0.25. So will be x5, okay, because k is 5, and 0.25 is alpha, and the difference between 5 and 6, okay. So 5 plus 0.25 times the difference is 1, so it's 5.25. So the IQR will be 5.25 minus 1.75 is 3.5. So you can see this method 3 is very different from method 2. Okay, so there's no hard and fast rule and tell you how to measure interquartile range. But interquartile range by itself, as we said, is not really tell you a lot unless you compare two different set of data, right? Because mean can tell you something, IQR can tell you something, but usually you used to compare two data sets, right? You say this data set is more diverse than other, right? So that standalone usually you don't compare, but usually you compare different data set. So that's why as long as you compare two different data sets using the same method, so that shouldn't be a matter. Okay, that's the end of the IQR. Thank you.